Okay, so we're going to briefly talk about something called singularity functions. And they are these very weird functions. In fact, mathematically, they're not functions, but to try to explain what that means would be way more than involved than this class can handle, certainly online. But really, we just need to have two special functions that we're going to talk about. The first is called the unit step function right here, u of t. And if you want to write it as a piecewise function, it's 1 if t is positive and 0 otherwise. So basically it's a graph that is starts out at 0 and then jumps up to 1 at 0. Now, if you look at this, we connected them there. And mathematically, that's a bad idea, right? You can't just jump up there. It's not continuous anymore. But we do, it's not a continuous function. You can't just jump like that. But we do it anyways in engineering. We don't really care. And the second function that we're going to talk about here is the delta function. It's called the unit impulse function here. And this one is this function right here, delta of t. This one's even weirder. It's infinity if t is 0 and 0 otherwise. It's a really, really strange function. However, it has very nice properties for us that we'll see later on. For now, just understand what these symbols, they mean these two things here. And there's one fun fact here, that delta of t is actually the derivative of u of t. We're not going to use that much in this class, but it is something that is used otherwise. Also, one last thing here is, if you look at this middle graph here, let's suppose you wanted to change your graph to where instead of it jumping up at t equal to 0, you want to jump at 5. You would have t minus 5 here. And then what your graph would look like is, it would be 0 up until 5, and then that's when it would jump. And so using this, you can have a jump happen at any time, positive or negative time. You can also combine these in interesting ways. For example, let's do u of t plus 2 minus u of t minus 3. And so basically the first one activates at t equals negative 2, and the second one activates at t equal to 3. And so what happens is, starting out at 0, the first one activates and it jumps up, positive 1. Then we get to 3 and it jumps down, negative 1. And so this would be what our graph would look like. And the reason why this is important is mathematically, this would correspond to, you flip the switch on, starting at negative 2 seconds, and then after 5 seconds you hold it, and then you let it drop, and you turn it off. So using these functions is a way to describe how it works when you either turn on or turn off a device. It's a really convenient mathematical description. We really are not going to use these that much, but there is one little fun fact I wanted to tell you. We did a lot of Chapter 7 problems so far, and every one of them I told you it was important to know that when you have a voltage across a capacitor or a current through an inductor, it can never change instantaneously. And that was what we relied on for everything that we did in Chapter 7. And so now I sort of get to tell you that that's a lie. That in fact, if you have a delta graph in your circuit, you actually can change the voltage across the capacitor instantaneously, or the current through the inductor instantaneously. The nice thing is we're just not going to do that. So if you go further in electrical engineering, you'll have to deal with that. But for right now, we're going to leave it as it is.